these are numerical variables, so we are taking them. For dummy variables, you have to use if statement and create dummy columns again. That's a complex process. But we don't want many variables. You can't write an equation with that many variables. You can consider, but how will you write equation? You guys are not comfortable with 5 variables only. How will you write with 18 variables and equations? All right, all of you copied these columns. Now we have to create a dummy variable for churn. Is equal to if equals to comma 0 comma 1 double quote space is equal to h2 double quote space f capital false, and then there is a full stop also. Is equal to if, let me zoom it a little bit so that you guys can see it. H2 is equal to double quote space f capital LLCE dot double quotes close comma 0 comma 1 double quotes space and then false f capital, and there is a full stop after false also. Double quotes space did you give space after double quotes space f capital double quotes, give a space and then f capital. Now copy the headers, don't copy the churn, copy all other headers, give 3 columns gap. From the third cell, transpose. We will have intercept in the first cell 0.05, 0.05. Assume some basic coefficients. Copy the headers, intercept and the variable names, and assume some dummy coefficients of 0.05. Headers and the variable names. Below paste, there is an arrow. Click on that and you will get a paste special window. There you will see transpose. Now we will calculate the value for Z. We will calculate the value for Z. Z is equal to Fn plus F4. Intercept is common for all. Fn plus F4. Coefficient of account length. Fn plus F4 multiplied by the actual value of account length plus coefficient of number of voicemail messages. Fn F4 multiplied by actual value of number of voicemail messages plus coefficient of number of customer service calls. Fn F4 multiplied by actual value of number of customer calls plus coefficient of total charges. Fn F4 multiplied by total day charge plus coefficient of total evening charge. Fn F4 multiplied by evening charge. Fn F4 multiplied by actual value. International charge. Fn F4 multiplied by the actual value with actual values. Coefficients have to be fixed by pressing Fn plus F4. You'll get a value of 11.528. Double click the formula, it will go down. So this is the calculation you have to input. Coefficient intercept plus coefficients into actual values. We have to take some assumed values. One is a larger value in the coefficient context. It has to be very small values, somewhere closer to 0 or less than 0.50. Closer to 0 will be better. All right. Then we will calculate 1 divided by open bracket 1 plus exp minus z. We have to calculate probability, which is 1 by 1 plus exp minus, that means is equal to 1 divided by open bracket 1 plus exp exponential open bracket minus. So first you have to calculate the multiplication of coefficients with then we will calculate the probability. All the coefficients have to be fixed. Fn plus F4. Enter. No shift enter. Shift enter is only, that is for different. This is simply enter. 1 by 1 plus exp open bracket minus z value. Now we will calculate the log loss. Is equal to minus open bracket y. Y is your churn dummy. Probability close bracket plus open bracket 1 minus into log of 1 minus. So this is the formula for calculating the log loss. Is equal to minus open bracket is equal to minus open bracket churn dummy into log of probability plus 1 minus churn dummy into log of 1 minus probability close two brackets. Press enter and double click the formula. See, this type of formulas you will be seeing in your data science. You have to impute them. You have to write programs also sometimes. Programming means using the existing functions in Python or R. These equations have to be coded into formulas. Whenever a new equation is proposed in a research paper, you have to code it into Excel sheet first and then you will code it into Python. Or if somebody has already coded it, if it is in general license, you can use it directly. Now we have to calculate average log loss. Average log loss. Sum divided by count is equal to sum of log loss, control shift down arrow, close bracket, divided by sum of log loss divided by count of sum divided by count. So after calculating log loss, you need to calculate average log loss, which is sum of log loss divided by count of log loss. Sigma n by n, mean or average. Now go to the data tab. We will use solver. Objective cell is the average log cell. Minimization. By default, it will be maximization. Change it to minimization by changing the variable cells. Select the coefficient range. By selecting the variable cells, select the coefficient range. Mark unconstrained. So solver, these are the arguments you have to give. Objective cell is the average log loss cell. Minimization, you have to choose the min function. Then changing the variable cells, the coefficient cells. Untick mark unconstrained variables and then click on solve. Average log loss cell. This window cannot be zoomed. That's a linear programming method. Only simply close, say okay, that's all. So predicted churn is equal to if greater than equal to 0.50, comma 1, comma 0. Probability is greater than equal to 0.50, comma 1, comma, and you double click it. It will calculate the predicted churn class for all the observations based on the probability. This is probability also changed. See, all the probabilities have already changed. Initially, they were all 0.99. Because we have adjusted the solver and everything is interconnected in solver, all the probabilities also got corrected based on the coefficients. Now, using that probability, the classification rule, probability greater than equal to 0.50 will be classified as 1. Probability less than 0.50 will be classified as 0. Simple if statement of probability. Classification rule, that is the standard classification rule for all classification problems. Yes, it will split the probability among all the classes, 0 to 1. The class that has the highest probability will be the final predicted class. 0 to 5, 0 to 1 only. Probability will always be 0 to 1. It will split the probability values in the classes. Whichever class has the highest probability, that will be our predicted class. Yes, average log loss. Minimization is the function. So this is the confusion matrix. 0.8632 is the accuracy. This is the accuracy calculated based on confusion matrix. Confusion matrix I have created using churn dummy and predicted churn. Churn dummy and predicted churn, I have created the confusion matrix. When I calculated the accuracy, it is 0.8632. Now, if you do the same thing you will get the similar outcome. So account length, number of voicemail messages, number of customer service calls, total day charge, total evening charge, total night charge, total international charge. So these are the variables, right? Y is equal to df dot, x is equal to df dot, comma axis is equal to 1. From sklearn dot preprocessing, import label encoder. Y is equal to label encoder dot fit underscore transform of y. From sklearn dot linear underscore model logistic regression. Logit is equal to logistic regression. Logit model is equal to logit dot fit x comma y. Logit model dot score x comma y. 0.8632. Exactly what we got in Excel. Logit predict is equal to logit model dot predict pd dot crosstab. We got the exactly same confusion matrix also. 0.8632 is the accuracy. If you look at my accuracy, 0.8632. Exactly the same confusion matrix you will get in this Python also. So this is the process of doing logistic regression in any software. Solver is used to minimize the error. Solver is the preferred mechanism used to minimize the error by changing the coefficients. Even the coefficients will be same. We got these coefficients, right? So we can check the coefficients also. Logit model dot intercept minus 8.00. X dot columns, comma, logit model dot coefficients. We'll get the exactly same coefficients. PD dot data frame x dot columns dot 2 underscore comma logit model dot coefficients. See, you got the same coefficients, right? In your Excel, you will get the same coefficients. Number of customer service call 0.46. See, number of customer service call 0.46. So this is the process of calculating logistic regression. So in logistic regression, the most critical part is minimization of error by adjusting the coefficients. It minimizes the error by adjusting the coefficients. It's an iterative algorithm because solver uses multiple iterations to reduce the error. And the lowest error possible, the solver will give, and accordingly the coefficients. Based on the coefficients, we will calculate the predicted probabilities. Based on the predicted probabilities, we will calculate the predicted class. And using the predicted class, we create the confusion matrix. Actual class and predicted class, we create the confusion matrix. From confusion matrix, all other metrics are calculated. Okay. So this is the process of logistic regression. Now you need to understand the whole purpose is to make you understand how the logistic regression works, how it works. You have to explain in simple terms that we initially assume then we calculate the sigmoid or probability, then we calculate the log loss, and then using the solver, we reduce and giving the log loss as objective. By changing the cells of coefficients, we get the final coefficients, and using that coefficients, we do the predicted probability. And using the predicted probability, predicted class is calculated, and predicted class and actual class are used to calculate the confusion matrix. And the confusion matrix will lead to accuracy and other metrics. So simply you have to explain in simplistic terms, right? The process you need to understand, because if tomorrow algorithm does not fit, you need to explain to the client why it is not fitting. It can be because of too many categorical variables, logistic regression fails. If there are too many categorical variables, logistic regression fails. And a logistic regression also fails when the probabilities are not calculated properly. When numerical errors or infinity errors come into your probability calculations. In the previous example, we are getting number error. I try to replace it with 0 or closer to 0 value if you can try, still we didn't get the coefficient. In that case, logistic regression will, that means imbalance in the data will also affect your logistic regression performance. That means zeros and ones, if there is a huge difference between zeros and ones, your logistic regression will also. But this is the process behind the functioning of logistic. Okay. In software, you will not get all these things. It just gives you the coefficients, intercept, and the accuracy. But how it goes through, you need to understand tomorrow, because when anything doesn't work, you need to have the basic understanding of the model. Otherwise, you cannot correct the. Here's what we have seen. People don't understand the algorithm. They get stuck saying it doesn't work. If you bring small changes to data, your algorithms will start working very well. So this is it. You can take your break and we'll meet at 11:30. So missing values in 1, 2, 3, 4. Torque is also numeric, right? 4 numeric and 1 categorical. Number of seats. 4 numeric and 1 categorical. We can use mean or median imputation for categorical, mode or most frequent. Car data dot engine. So engine is a whole value. There are no decimals in engine, right? It's a whole number value. So what type of imputation will you do for this data? Which one will you do for this data? Median. Because median will give a whole number. Mean will give you a decimal number. Median gives you whole number. So here the imputation should be for engine should be median. Like before you came, we were discussing about mileage. Mileage is decimal. We can do mean imputation later. We can do mean imputation for. Similarly for torque. For torque, what will you do? So torque is also whole number. Median imputation has to be done. Similarly, max power. Max power we also check is decimal. Max power and mileage are decimal. So if you are looking at the variables, max underscore power, mean imputation, median imputation, mode imputation. First do the imputation, later outliers. How will you do outliers, everything before that? First do the imputation, then we do the later outlier analysis. Mileage is equal to car data dot mileage dot fill NA, car data dot mileage dot mean. Car data dot max power is equal to car data dot max power dot fill NA, car data dot max power dot mean. So max power data is object, right? Why it is coming as object?
One value is
215 is there. 215 max power means 7913 plus 215, 8128, right? It is null only. Acha, you have these things, right? That is the problem. We have replaced it. Then why it is giving us again the error?
by giving space in that quotes.
Space is there, huh? There is a space. Yeah. Now we got it. Okay. So when you look at the error, you will see as type, when you try to convert, it will point to the specific error. So here, quotes was the problem. That is why it is showing as object. Similarly, what other is showing as object? Torque, right? So car data dot is equal to car data dot as type int 64. Because it's a whole number, na? Now when you do this, it will go to the error. Cannot convert float NaN to integer. Huh?
4500.
Float NaN to integer. Only one value is there, na? So we can try fill in a 0. What did you do?
No,
Still we're getting the same error. So replace didn't happen, huh? Replacing with 0 also is not working, right? So we have options like fill in a with 0 or numpy.nan. We have 4500, right? Oh, we have errors is equal to coerce here. Shit, I forgot this thing. Car data dot store is equal to pd dot to underscore numeric. Car data dot comma errors is equal to coerce. Dot fill na car data dot store dot median. So whenever you have such problem of commas and all in your numbers, use pd dot to underscore numeric and errors is equal to coerce. What errors is equal to coerce is wherever it is not able to convert. Errors is equal to coerce if data type is not converted, the cell value will be replaced with NA. So errors is equal to coerce. Wherever it is not able to convert the data type, it will impute NaN or NA in that cells. Once it is imputed with NA, we can do fill NA with median. Okay. So this is the pd dot to underscore numeric. What is the doubt? Engine is there, right? Car data dot engine is equal to car data dot engine dot fill NA car data dot engine dot median. Fill NA with median. You can do that same thing here with max power also. Instead of doing this np.nan, we can do to underscore numeric. It will automatically insert, convert it into float, or you can directly do mean imputation directly.
So np.nan is a object.
np.nan is a unique default type. It is neither object nor numeric. It is a default data structure. It is a null data structure. It is treated as null. So we will follow the same process. Let us say pd dot to underscore car data dot max underscore power comma errors is equal to coerce. Then we don't need this. Okay, fill in a mean. So median car data dot seats is equal to car data dot fill NA car data dot seats dot value counts dot idx. So these are the missing values. Imputation. Let me check the data frame if it is worked or not. 8128, 8128, all the missing values are gone. So you can use these methods to do missing value imputation. To numeric will change it. Why will not it change? This is the right method. To underscore numeric will change it to the relevant data type. If it is float 64, it will change to float 64. If it is int 64, it will change it to int 64. But that's a double step procedure. No? This is one single step procedure. See, in data science, there is different ways, but you have to find the right way of doing it. The right way will be where you have the reduced number of steps. All right, can you move forward? Object calls is equal to car data select underscore d types include is equal to square bracket single quote object is equal to car data dot select underscore d types include is equal to np dot number. Object calls dot head object calls is equal to object calls dot drop name comma axis is equal to 1. I'm dropping the name column which is not required. Numeric calls dot columns. So we have year, selling price, kilometer driven, mileage, engine, max power, torque and seats. Based on the year, we will calculate the age and then we will drop it. Then seats also separated as categorical variable. So 5-seat car, 7-seat, 8-seat, 4, 9, 6, 10, 2 and 14. We have different seat cars. Majority are 5-seat cars. So seats is a categorical variable. numeric calls square bracket age is equal to numeric calls. We have decided we'll age of 2022, right? So what is the name of age? So object calls square bracket. The name of the variable is seats is equal to numeric calls dot. We are moving it to same. The label encoding will be done. Why to create another data frame? One variable, add it to the existing object calls. Anyway, you have to do label encoding on same, or we'll do get the miss. So numeric calls is equal to numeric calls dot drop square bracket single quote seats comma year comma axis is equal to 1. There is no index here. Where is index in this variable, in this data? We have not gone to that step, right? When will you know whether to reset index or not? When your concatenation gives you an error. Otherwise, how will you know when to reset or not? We have not gone to that step yet. No, there is no such thing. It depends on data structure and the data we are dealing with. If that gives a duplicate axis error, then you have to reset. Until unless it generates an error, you should not do it. Not that info. We will not find index in info. So we have dropped these columns, right? Now, object calls. So before we go there, you have done the hypothesis test. What hypothesis tests are there? At this point, you have to do hypothesis testing. Before label encoding, you have to do hypothesis testing. Object calls underscore dummy is equal to pd dot get underscore dummies. Object calls comma columns is equal to object calls dot columns. Now we have dummy encoded. Object calls underscore dummy dot we got 23, whereas original object calls is 5. Once you get dummy, it went up to 23 columns. Now, numeric calls dot head. We have different values. We have to scale them, but you should not scale the selling price. Selling price is a dependent variable. So you should drop it and scale the remaining variables. So numeric calls underscore scale or numeric underscore scale. Oh, sorry, we have to import the function, right? From sklearn dot preprocessing standard scaler. Or what type of scaling can be done? That also we have to look at it as SNS dot. So we can see the box plots of selling price is there, but other things we are not able to see. Let us drop underscore price comma axis is equal to 1. Oh, kilometer driven is giving us a bigger plot. Rest of all are small. Selling underscore price. What is the other numeric variable? km underscore driven. We're not able to see it correctly, right? But there is too much of skewness is there. But what about others? Do we have outliers in others? Numeric calls dot km underscore driven dot plot kind is equal to box comma work is equal to false. Positive skewness is there, right? You can do multiple box plots. Very few outliers for each. So very high skewness in selling price. Kilometer driven also very high. Rest of all are low. So shall we use robust scaler, which will take care of the outliers also? Underscore robust is equal to robust scaler dot fit underscore transform numeric calls dot drop underscore price comma axis is equal to 1. Numeric underscore robust. So it says numpy array. So we have to convert it. Is equal to numeric pd dot data frame numeric underscore robust comma columns is equal to false dot columns square bracket -1. Okay, square bracket -1 might go to negative indexing. Last it will go to last. So we have implemented the robust scaler. So we have label encoded the get dummies. We have done the get dummies on object calls. We have also done the numeric call scaling because the values are in different format. Combined is equal to pd dot concat square bracket numeric underscore robust comma object calls underscore dummy comma axis is equal to 1. See, it can give you index error. That index error comes when you have done scaling or on multiple times on multiple data frames. One data frame, if you scale, it will not give you that error. Combine df dot shape 29 variables 8128. Now combine df square bracket single quote selling underscore price is equal to numeric calls dot selling underscore price. Dependent variable is not there because the robust scaling we have dropped the selling price. Y is equal to combine df dot selling underscore price, x is equal to combine df dot drop underscore price, comma, axis is equal to 1. Y dot plot, comma, what is equal to complete positive skewness. Now, np dot log, it moved box to the center as well as split the outliers. So this looks like a stable data. This looks like a stable data. So we have to do logarithmic transformation that will do it on dependent variable. Why we are doing this? Because our dependent variable is positively skewed. From sklearn dot linear underscore model, import linear regression. Reg is equal to linear regression. Reg model is equal to reg dot fit x comma np dot log of reg model dot score x comma np dot log of y 86.92. This is your r square. R square of 86.92. Reg predict is equal to reg model dot predict reg receipt is equal to y minus reg predict. np dot sqrt, np dot mean, reg receipt. So 1,01,02,869. We got some error here. 1 second. What we got as reg predict. Now we have to convert them. Reg predict is equal to np dot exp of reg predict. We got the values now. Now we can do the deduction. Oh, it went up 3,21,433. RMSE is there. 3,21,433. So this is the process. All of you have done the missing value imputation. You can go from here. Or you want me to send the notebook, I'll send it to you. Each of you might be in different. In your home tab of Jupyter Notebook, you will see downloads folder. You can access this notebook from there, and you can implement the whatever, wherever you have missed the things, you can do it. So one thing you need to remember is 2 underscore numeric. Whenever you are converting an object data to numeric data, use pd.2 underscore numeric, errors is equal to coarse. Whenever you are trying to convert an object data to numeric data, pd.2 underscore numeric, errors is equal to coarse. Now this you should use when you have very small number of errors, that object types are very small. If they are in very large numbers, then we have to do the replace function. We have to use replace, and then we have to replace them and all. Here we are doing this coarse because only one or two values are there. But in real time, what happens is you will have half of the values without comma, and another half of the values will have comma. There we should not use errors is equal to coarse because we have values, right? So there we have to replace the comma with space. Then we will remove the space. Then we will remove the space using the string function. Then we will remove the space. Then we will get the complete. Then we will change it to float or. So the decision to implement pd.2 underscore numeric depends on how many of those values are there. If very few values are there, that is going to cause problem. You can run 2 underscore numeric, errors is equal to coarse. Wherever it can't convert the data type, it will simply put it as NA. But in some data we have seen, one Medicare data we worked on earlier batches, guys. There, one place we have half of the dollar values with comma, then some dollar values with dollar symbol, some values without comma or without dollar sign. Now we can't do anything there. We can't do coarse here because then everything will become missing values. 2,80,000 rows are there. So we can't do this. So we have to replace comma, we have to replace dollar, then we have to remove the spaces between those numbers. Then we will make it into one number. Then we will have to run float 64 to convert it into. So that complex things will be there. So you have to look at the data. You have to look at and then you decide. Not that everything will have to be same process. It depends on the data type and the data structure. And you need to change based on that. Here we don't need to do indexing because it concatinated without indexing. But if it has given a duplicate access error, or if it says duplicate index is found, then you have to reset the index of both the data frames, and then you have to concatenate it. Go and do it before. Once you get the error, then you correct it. Read the error in the last line, you will get it. Copy paste the error in the last line into Google, you will get the solution. 99.9% you'll get the solution in Stack Overflow. If you copy paste the exact error from the last line, in that error you will see the last line, right? That you exactly copy paste, you will get and choose the most recent solution. Once you put it in Stack Overflow, you will get see here, you get the ES. See, this is 2017. This is 2020. So you can click on this 2020 error, and then he has used fill NA as type, or he has suggested, this guy has suggested multiple solutions, method 1, method 2, method 3. So you have to find the best possible solutions, and then you will impute it according to the requirement. So you cannot say this will always work. So you have to be ready to work with different types of solutions. Sometimes we have to select them. You know how to select those things, right? We just select the null value columns, and then we'll check the values. So these are the common errors you will find in real-time data science. In hackathons and also you will find these common errors. So you should be able to tackle those errors. You should have ideas. If you are not finding, search on Stack Overflow, understand the code and implement it. Stack Overflow also, DF means you change the data frame name of whatever you are using. Give in square brackets, you give the column name, whatever is your column, and then rest of the thing should simply copy paste the thing and then change the data frame name and the variable name. That should be the debugging process. Any doubts in that, Kardeko? Remove space in, see here, you have spaces, right? We want it to be full number. You can use this solution, regex. When I talk about natural language processing, then I will talk about the regular expressions. /D means digits plus /s plus. This is the standard syntax with where we can do it. Or you can simply say question mark less than equal to /D, question mark is equal to D. This can remove the things in the string. Or you can find any other between numbers using Python. This is also common problem. See here 1 mg, medical data. Take mouth 1 unit, 1, 2, 3, 1 mg, some medication data is there. Na? See here, /s denotes any white space. /t, then he has given this thing. See, or positive look behind and positive look ahead assertions. These are zero length assertions, and you can remove the. So here, this is even complex task compared to the previous task. In previous task, we just need to put it in numbers. Here, different numbers are there with different spaces. This is even more complex task. And they have given a complete explanation also. See, if you read it, they'll give you the explanation. What that question mark symbol means. See, question mark less than equal to /s. Question mark is equal to /d plus s, 0, no spaces, print leading zeros. Explanation is also given. So you just need to debug. Transformed value, no? Oh, I forgot that also, right? Oh, sorry. Oh, I did the reg predict. That's why I thought, how come that is such? Y is equal to np.exp, right? Now, what is the y values here? Oh, y values are actual only. It didn't change. It changed in the model. The outcome prediction was logistic, logarithmic. That we have converted here. Then why we got infinity error here? Model. Regressive. We got the values. Yeah, this model has failed. Why we need to subtract from log transformed one? These are not log transformed values. No, residual is actual minus predicted. Both of them should be in same scale. This predicted I have converted into actual values, right? See, you cannot use one log value and one actual value, one numeric value to do it. That is why I converted the predicted values also to numeric values. Then I did the residual calculation. You cannot have one in logarithmic, the other as number, and do the residual calculation. Both of them should be in same mathematical units. Now, reg predict is also numeric one. Y is also numeric, and then I am calculating the residual. That is a formula here. Root mean square error is the formula given for calculating the residual. That is a defined formula in statistics for calculating root mean square error is the diagnostic. What is the reason is that is a formula they have devised. Square root of mean of some square error. That is a formula predefined. If you want to go to derivations, you can look at the Gujarati's regression book. There is a 700-page regression book by Gujarati. There he will discuss all derivations of regression equation. Around 200 pages is only regression only. You can look into that book. There you will get why RMS is derived like that. The equations, the derivative calculus, everything you will find there. Because these are fixed formulas derived from matrix calculations only. So everything you will find it in Gujarati. Econometrics Gujarati regression is discussed around 200 pages. Everything what we use is detailed derivative and description, calculus, everything will be there. These are predefined formula. Root mean square is a predefined formula, which is a diagnostic for all regression problem. Any regression problem, ultimately you have to calculate RMSE and you have to compare RMSE of one model with the other model. It's as simple as that. So the RMSE is very high. The root mean square error is very, very high. Now, if I use a standard scalar, will it change? That also we can check. Instead of robust scalar, if you use standard scalar, what is its impact? Same slide lower in RMSE, but scaling, standard scaling also did not bring any change. So for this model, linear regression is not the best fit model. So if you are looking at other models, we can tell it. 16,019. The next model which we are going to study. Such a drastic difference in RMSE. Just completely reduce the RMSE from lakhs to, so the change of model is what required in this data. MLR has failed. So you have to look for an alternative model. No matter what you did do pre-processing also, it didn't work. So the best alternative is you can consider decision tree, then you can build random forest, you can build gradient boosting, you can build whichever gives you the lowest RMSE, you will go with that RMSE. Yeah, we have to do them. No? Next is decision tree only. Decision tree by default overfits. But when it run on the test data, it will underfit. By default, it will overfit, but later it will, when you put it on a test data, it will stabilize. Why it is overfit, you need to understand the calculation methodology, then you will be seeing why it has the ability. That is the disadvantage of decision tree. Any data, it will overfit. But if you implement it on test data, it will give you a proper accuracy or proper RMSE. So tree-based models, that is the problem. Overfitting is a problem, but when you run it on test data, it will have good performance. So once we understand the calculations between the tree-based models, you will understand why it will overfit. Okay, so we'll stop it here. In the next session. Say textbook says you can remove outliers, but in real-time data science, the outliers have some significance. You can't remove them. Textbook says you can delete those things, you can cap them with a mean, you can cap them with a median and all. But if you are looking at retail sales, some stores will outperform. There will be outliers. Some stores will underperform. There will be outliers. Then if you cap the outliers of best performing stores, will your model be able to predict properly? That means you are creating a problem. In bank accounts, you will have people who has average balance in, average monthly balance will be in lakhs, 20 lakhs, 30 lakhs. You have people whose average balance is zero, or some people who has average balance is negative, because banks put, if you don't maintain minimum balance, they put 1,000 rupees, right? Minus 1,000, minus 1,000, minus 1,000. That means next time when you deposit, they'll detect all these things and then they'll put this thing. So you'll have outliers. There, can you remove them? Those higher average balances are, you have to understand those people. They will buy your credit cards. They will understand these things. You should not issue credit cards to less average or negative average balance guys. There, the negative and the high values are very important, right? Then if you cap them, can you use the trend? See, in outlier treatment, dropping is one option. Capping means replacing with mean, median, or nearest maximum, nearest minimum. Okay, all these methods are there, but these methods will distort your data analysis. In case of textbook data, that's a different scenario. But in real-time data, the outliers are very, very significant in your analysis. Even in sales data, retail, what you call normal sales, marketing sales data, there will be some executives who overachieve their target, 200%, 300%. There will be sales executives who will underachieve their target. Both are outliers, right? Overachieving is outlier, underachieving is also outlier. Now, can we remove that? You can't, right? You have to take them into consideration and then you do analysis. So outliers, what textbook says is different from what we do in real-time data science. Now, when you have outliers, the base model will fail like this. Now, tree-based models like decision tree, random forest, and gradient boosting, they are very, very good models when you have outliers. They are resistant to outliers. Skewness and outliers are there. Generally, people will jump to decision tree models, tree-based models, because they are not affected by outliers. They are not affected by outliers. They perform very well. Base model will not work if you have outliers. No matter what you do, the tree-based models are best when you have outliers. The single tree model, which is the decision tree, and the multi-tree models like random forest and gradient boosting. Now we got new models, extra tree classifiers, extra tree regressors are there, conditional inference trees are there. There are different types of decision trees also being developed, which are very robust and very strong. Again, neural networks will fail. In neural networks, you have to fine-tune, pre-process, all those things you've done properly, then neural networks will also give you the best model. But neural networks require a lot of computing power, lot of pre-processing, lot of which you don't need to do in tree-based models. I didn't do anything. Even I didn't do logarithmic transformation of y. It gave me a model with RMSE of 16,000. This is the advantage. So you have to understand. We will go one by one model, then you will be able to understand how each model works and how each model fails. Now the base models fail when you have outliers. So remember, outliers are very, very critical in data science, in real-time data science. Textbook data, whatever you want to do, that's different. But in real-time data science, outlier signifies performance, either an exceptional performance, under performance, or worst performance. And when you are building a model based on the performance variables, delete them, you cannot ignore them, you cannot cap them. You have to take them as it is. Then only your models will work properly. So outliers, you have to keep them. The basic solution is in interviews they ask, what will you do with outliers? You said, I'll try to see scaling. Scaling will keep the trend. The larger outlier will get a larger value compared to the smaller value. The larger value can be 2.3, smaller value will be 0.8, but that difference is not a big difference, right? In a model, they are treated different. But in a model, if you give 5 lakh and if you give 1,000, that model will be biased towards larger values. The model will always be biased towards now that will create, to avoid that, we need to be very careful when you're dealing with this thing. This you'll understand as you go through working different data sets, you will understand when to use what and how to use. And remember, you can't implement same thing again on same data, or different data. It has to be based on the data. Your strategy will also change. Your strategies will also change based on the data here. So this is your car deco. I have already sent the file and the Excel sheet which we worked upon. You can keep them as reference. And please start reading the theory parts, whichever is there. The theory is very important. Now, from now onwards, theory will be there. Theory is very important in interview. And also keep your SQL practice going on. Whenever you have time, please practice your SQL. Okay. Whenever you have time in a week, you allocate 3 hours to SQL. Otherwise, you will forget it. Okay. There are databases in SQL. Which database you worked upon? No. Which data? Employee data, right? So you practice queries on the employee data only. There are a lot of queries available on internet, right? You can use those queries to run queries. Please do at least 3 hours in a week on SQL. Otherwise, you'll forget it. SQL is also very, very important. So do that part also. SQL also is very important. Make sure you are practicing SQL regularly, right? Whether together we practice or individually practice. There are good databases also. Northwind is there, or movies data is also there. If you are interested, movies database is also there. IMDb movie reviews, sample database movies. This is also very interesting data set. You can download it. This is the schema. These many tables are there. This is a large database with movies up to 2016, I think. IMDb movie database only. You have this many tables: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 18 tables are there. So you can work on this type of data. You can easily download it from any GitHub.sql file, and the schema is also required. Which table is connected to? So this diagram will tell you how to which one to many to one, right? So this is one to many. So you have to understand this diagram also so that you can write the queries. These complex queries, write complex queries. You have to go beyond the basic queries, joining multiple tables, querying the data. But practice SQL, that is very important.